Imagine this. A hacker is sitting somewhere on the internet. No username, no password, no insider access. And yet, in under 5 minutes, they can take full root level control of your entire Splunk server. Every log, every alert, every security dashboard you depend on, gone. This is exactly what CVV 2025-3 make possible. And the worst part, the proof of concept of this exploit is already public. In this video, I'm going to break down exactly how this attack works step by step in plain English. No jargons, you will understand the flow, how a hacker actually exploit it end to end. Whether your system is vulnerable right now and three specific action you need to take today. This is CVV score 9.8. That's the second score possible on a security scale. Let's get into it. First, what exactly is Splunk? For those who don't know, Splunk is one of the most widely used security monitoring platform in the world. Banks uses it, hospital uses it, government agency uses it. It collect and analyze log across your entire network. So your security team can detect threat. It is essential. The is the watchtower of your IT environment. Now, here is where the vulnerability lives. When you run Splunk Enterprise on premises, it doesn't just run one application. It runs secondary component alongside, which is called PostgreSQL, which is sidecar. Think of it like a backroom assistant that handle your internal database tasks for Splunk. The main Splunk application, it has a proper security checkpoint and an authentication gateway. You need credentials to get in normally. But PostgreSQL is a sidecar endpoint. It has no authentication control whatsoever. None, zero, completely open to use. This means, and this is the key line, any person who can reach your network can send command directly to that side your SQL Grace server and then perform the file operation, creating file on your server, deleting data, modifying records without a single username or password. Now, here is it get really clever. Researcher at Watchtower Labs discover that inside this there are two recovery endpoints that can be weaponized together. Endpoint one, which is lived in the backup, recovery backup, and what does it do is it pull the database backup from the remote server and the attacker controlled server and drop it into a Splunk local file server, your system, so that the attacker database dump is now sitting inside your server. Endpoint 2, which is also dangerous, which is a post one, which location you can see here. It is used to load the database dump, the one that attacker just smugged in into Splunk local PostgreSQL instance. And there is a critical detail that the attacker database can be set up with passwordless authentication and a SQL function called as allow underscore export already granted permission is a feature that let you write the content of a database object directly to the file on the server file system. Do you see where it is going? The attacker just got the ability to write the file they want to your server. That is called arbitrary file write. And arbitrary file write is the one step away from your full system compromise. Let me walk you through the full attack chain. Now exactly what the hackers does. Phase 1. Smug the malicious database dump into a Splunk. Attackers set up their own PostgreSQL database server. This database contains the malicious dump. Essentially, the database file with hidden destructive instructions backed in. Step 1. They send a GET request to the backup, then unauthenticated endpoint. pointing to their own server. Splunk Sidecar SQL PostgreSQL server obediently pull the attacker's database dump to store it on the Splunk local file server. They send a post step two. Then they send a post request from a restore again. No credential needed. They also pass the password file argument point to Splunk own internal credential file at /opt splunk /var package postgres pg pass. This tricked the sidecar into loading the malicious dump into a live local Postgres SQL instance using a Splunk own credentials. The attacker code is now inside your database, inside your server. Now, phase two, turn a file write into a remote code execution. Remember the load/export, the SQL function that write database content into a file. The attacker malicious dump trigger it. Here, exactly what it does. It take a blob, which is a binary large object stored inside a database, and write it as a file directory into Splunk's file system. That blob, it's a malicious Python script. And where does it write the script? To a very specific location into an opt Splunk etc app Splunk secure gateway.bin, a directory that Splunk automatically execute script from. So the next time Splunk run or the attacker trigger the right endpoint, the script of Python executes. The script get permission on itself, run its payload, and terminal result is to be get root.splunk. And your RCA is secured. Attacker get the access of your Splunk server. Attacker can now read every logs and alert in your security system, deploy ransomware, create backdoor account, exfiltrate data, modify your security rules to hide other attackers, completely own the machine that was supposed to be protecting you. So, are you affected? There is an impact matrix. Check your Splunk Enterprise version right now. If you are running Splunk version 10.0.0 through 10.0.6, you are vulnerable. Patch to 10.0.7 immediately. If you are running Splunk Enterprise 10.2.0 through 10.2.3, you are vulnerable. Patch to 10.2.4 immediately. If you are a Splunk Enterprise 10.4 or higher, you are not affected. And if you are a Splunk Cloud, you are not impacted. Splunk Cloud deployment don't use Postgres SQL at all. So this attack surface simply doesn't exist there. The key phase here is on-premises deployment. This is specifically an enterprise or on-prem problem, but that cover a massive number of organizations, specifically in the sectors like finance, healthcare, and IT industries and government, where data residency requirement means many teams are still running Splunk locally. Here is the thing that you need to do today. Patch immediately. If you are a vulnerable version, upgrade to 10.0.7 or 10.2.4 right now. This is the only full fix. There is no workaround that replace the patch. Action 2. Monitor your recovery endpoint. Enable while even while you are arranging the patch, set up alert for any external or anomalies traffic hitting path version 1 Postgres recovery point on your Splunk instance. If you see unexpected request hitting that path, you may already be attacked. This is your early warning signal. Action 3. Network isolation. Ensure your Splunk management interface and sidecar port are completely isolated from public internet. These should never be internet facing. If they are right now, that is a fire drill moment. Take them offline from public access before you do anything else. There is a threat landscape reality. There is no active exploitation confirmed in the wild yet. but the proof of concept detail are now fully public. Security researchers have already done the hard work of figuring out the exploit, and that means attackers are replicating it right now. The window between POC published and active exploitation is shrinking every year. You have now narrow lead, use it for your advantage. If this breakdown was useful, smash that like button. It genuinely help the channel reach more security professional who need to see this. Subscribe and hit the bell so you don't miss the next deep dive.